So, the mole. The mole is a concept that is fundamental to understanding stoichiometry and also the techniques. This is a technique that is introduced in this chapter and later revisited in chapters 10 and 12. It's not a really hard concept to understand if I introduce it to you correctly, but I think that a lot of students have a lot of trouble with this concept. I'll probably be going over this in great detail, or your teacher will probably be going over this in great detail during their lecture, but I'll kind of introduce to you the way I like to look at a mole. If I say the word dozen, what is the first thing you think of? I'm assuming that the first thing you're going to think of is the number 12. It's because ever since you were a little kid, as soon as we told you the word dozen, we told you to associate that with the number 12. And so if you have 2 dozen, that means you have 24 something. And it doesn't need to be always eggs, because to be honest with you, when I hear the word dozen, I think donuts, which is probably why I've gained so much weight. But I think of, like, if I say 2 dozen donuts, I'm thinking immediately in my head, oh, that converts to 24. And I know to multiply 2 times 12 to get my 24. But if I go backwards and I say, well, I have 36 donuts, what do I have? I know to take 36 divided by 12, and instead of multiplying by 12, I divided by 12 this time. And I got 3 dozen of those donuts. Now, why did we introduce the idea of dozen in the first place? Well, because it makes counting easier, right? Like, it makes grouping things into smaller group or into piles easier. So, like, I can count the number of cartons I have or the number of boxes I have and immediately tell you how many donuts I have or how many eggs I have without having to count each one. 1, 2, 3, 4, 5, all the way up to 60. Oh, I've got 5 dozen. It makes things easier into bundling things. So if I gave you a bunch of eggs, what you would probably do is put them into the little 12, the little dozen containers, and then count how many containers you have, and you can immediately tell me how many eggs you have. That would probably be the easiest thing to do. Now, that requires some conversion factors with bridge notation and all of that kind of stuff. But for the most part, students have no trouble with this concept because this is a concept they've been using since they were little kids. So you can immediately be able to multiply by 12 or divide by 12 and know whether or not you're multiplying or dividing and all of that kind of stuff. The concept of a mole, honestly, is no different than the concept of a dozen. The difference is one starts with a D and one starts with an M. And I know you're thinking, wait a second, no, it's more confusing than that. And you're right, it is. But it really is the same idea and the same concept. And I almost feel like if you take that approach of saying, okay, well, I'm going to approach this like something I do understand, which is the dozen or a mole, then what I can do is then understanding a mole is much easier. Here's the thing. In chemistry, we're dealing with much bigger or smaller numbers than just talking about 60 things. If I had 60 things, if I had 100 things, I would probably break them up into dozens and then deal with it that way. But if I was talking about like how many molecules are on the tip of this pen? See the red part right there? Or the black? Well, let's go with the red part right here. See the red part right here? How many molecules can fit on that? We're not talking about 100 or 500 or 1,000 even, or even 1,000,000. We're talking about one with 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 of those molecules. It'd be like trying to count the amount of grains of sand inside of the Sahara Desert. You wouldn't put them into little baggies of 12 grains each, and then you wouldn't put them into little baggies of 12 grains each, and then count how many bags you have. That would be ridiculous. So what we would do is we would group them into these giant amounts of sand. Like, let's say, oh, if I had to see how much sand fills up this city, or, what I would do is I'd probably take the sand and fill up an Olympic-sized pool. And then I would say, well, that's about 10 Olympic-sized pools. So I'm grouping it into these bigger numbers. And that's what the concept of a mole doing is. It's grouping things into a much larger number of things. It's 6.022 times 10 to the 23rd power. So that would be 6022 amount of things. Whereas a dozen is just 12. So a dozen is kind of an easier number to grasp, maybe. But a mole is an easier number to work with when you're dealing with really, really large numbers and really, really small things. And that would be Avogadro's number. I like avocados. Again, going off of how much weight I gained because I love avocados. All right, stoichiometry. This one's one of my favorites. A lot of people get really tripped up on stoichiometry, and I'm going to have to say, stoichiometry is yes, it is hard, but I feel like the concept of stoichiometry itself is actually really easy. It really is. It's easy. The hard part about stoichiometry is that we're going to play some punk moves on you, and in order to cross this bridge of stoichiometry, that's really easy. But in order to get to the platform so that way you can cross the bridge, that's where we can trip you up. We can give you an equation where we just give you the names of the elements and tell you that they combine. Well, the trouble that you're going to have now is now you're going to have to go back to chapter 6 or whichever one it was, where we talked about nomenclature and how all of these things came together, and then understand those concepts. And then you're going to have to use the molar mass to convert it from the formula to the moles that you have, and then you can go across the stoichiometry bridge. We'll explain it to you as the chapter progresses. But anyway, this is a really important concept. And I think that if you kind of approach this like, wait a second, my teacher promised me that this could be easy for me if I understand it correctly, and keep that in mind, and don't get bogged down by, oh my goodness, this thing looks so hard. Because it will. It will probably take you a whole page to solve one of these problems. One problem. I assure you that it's not really that hard. It just has 5 relatively easy parts all placed into that one problem. Which that's what makes it hard, is keeping track of all of these easy concepts that you've learned back in chapters 1 through 8. Putting it all together, that's really important in stoichiometry. And I think, what is the last thing we learned in this one? Or we just hit more stoichiometry. Yeah, more stoichiometry. All right, have fun with that.